Alright, so let's start and do this the right way this time, hopefully. Please stop me if I go completely off track. So now I'm looking for 9.45 moles, so I'm going to write the given this time, and I'm going to write what it says. Alright, so I have moles of aluminum oxide. Okay, so again, I don't want the moles, so I'm going to make a little bit of straighter line. And whatever units I start with goes down here. Okay, so again, I'm matching up units to units, and I do that, why? Because I want them to cancel. Okay, so now, on the top again, what goes on top? Grams, because I can always go from moles to grams and vice versa. And I just showed you I could do it the opposite way last time. And so again, I take my formula, I put it down here. And from my formula, I have 2 aluminiums and 3 oxygens. That's my formula. And then my molar mass I get from my periodic table. So I go to aluminum, what was it, 27? Thank you. I have a short memory. And oxygen, I go to my periodic table, I look it up. And I add those together. And it's still 102 grams. So 102 grams in 1 mole. Now again, this is the most often mistaken thing is people flip these numbers. Okay, 1 mole is what we want. That's a lot of grams. Cross off my like units. Now, hey, I'm in grams. The question says what is the mass? So I've set that up right. And I just multiply across and divide.
Wait, how did you set this time? What did your time?
Alright, so number 16 here. Again, I'm going to write my given. Whoa, stop doing that. And, okay, so I don't want the given, so I'm going to put the units down here. And on top, of course, I don't want grams. I do want the moles. Alright, I don't want moles, I want grams. Okay, it's always 1 mole, because the periodic table always tells me 1 mole. It's never going to change. Okay, so then off to the side, I got to figure out the molar mass. So I have 2 things. I have carbon, I have hydrogen. That comes from my formula. I have 20 carbons, and I have 42 hydrogens. That's my formula right from there. I go to carbon on the periodic table, it's 12 grams. I go to hydrogen, it's 1 gram. I multiply those. And I add them together. And I take that number and I put it up here. Okay, I'm going to cross off my like units. And then my setup is done. Now from there, I'm going to multiply 4.52 times 282. I take that coefficient, that one. I just put my 10 to the third after that.
Do you have small timer then, or they can just
Now, I'm going to go ahead, I'm going to multiply them together. And it's about 1270. And then to put it in proper scientific notation, I have to move my decimal over 1, 2, 3 spaces. I just made this smaller by a factor of 3, so this has to get larger by a factor of 3. And then 10 to the 0 equals 1. And so that's my answer. 2.50 moles, number 17 here. I don't want the mole units, so I always take my given and I put it down here. And in this case, it asks for the mass. Mass is grams. Okay, it's always 1 mole, because that's what the periodic table tells me. And then I just have to figure out the mass of this. So I have a single iron. My 2 is distributed to the O. So I have 2 O's, 1 Fe. And my 2 is distributed to the hydrogens. Now I don't know why, but different people's periodic tables will give you different values for Fe. So I'm just going to round it to 56 grams. Some of you will have a different value, so just use whatever you got. So I look up all of these guys. So as long as you're in the ballpark. So I got 90 grams. That is my molar mass, 90 grams for 1 mole. I cross off my like units. I'm in grams, that's what the question asks for. I multiply that, and it's about 225 grams, depending on what you round it to. Alright, so then we just have a problem going in the opposite direction. So they give us grams, and they ask us for moles. So again, we'll do the same exact thing. We'll start by writing the given. Okay, I don't want the given. So I put my units down here. I'm in grams. The only thing I can change grams to is the mole. How many moles? It's always 1 mole. Okay, how many grams? Well, it depends. So I go to iron. My formula tells me 2 irons and 3 oxygens. I go to the periodic table, I look up iron. We're going to call it 56 today. And oxygen is 16 from the periodic table. I add those together. That number goes up there. That's my molar mass. I cross off my G units. That's right. And I multiply or divide that. 92 divided by 160. It's about, depending again on where you rounded it to. All right. 0.578.
So you get 160 times 92.
Alright, so for number 19, there's your formula, N2O3, that's dinitrogen trioxide. Doesn't work. Okay, so again, we're going to start by writing our given. But I don't want the given. Ooh, that was a nice line. But I do want on top, I want moles. That's the only thing I can change grams to. It's always 1 mole. And when I go to my formula, it's N2. So there's 2 nitrogens, O3, 3 oxygens. I go to the periodic table, I look up nitrogen. I look up oxygen. I multiply across. Whoops. I multiply across. I add them together. Put it up here. Cross off my like units. Okay, I'm in moles. The question says moles, so 75 divided by 76.
I know what I did wrong. I multiplied.
No, how did you get 76?
Alright, so one more conversion factor. Avogadro's hypothesis. Back in the day, he came up with this idea that any mole of any gas is going to take up the same volume, assuming they were under equal conditions. Why? Well, if you look at these both of these gases, most of them are made out of empty space. So no matter how big the molecule is, most of it's empty space. If I take 2 people in the gym, it doesn't matter if they're 5-year-olds, 40-year-olds, their size doesn't matter because most of it, again, is empty space. So Avogadro's hypothesis said, and again, this is under equal temperature and pressure. It's called standard temperature and pressure. And we'll talk more about this later, but STP just means we're at 0 Celsius and a certain given pressure, these pressures. So under the same conditions, 2 gases will have the same volume. 1 mole of any gas will have a volume of 22.4 liters. Okay, and that's on the back of your periodic table, so you don't even have to memorize it. You can see here what she's holding is 22.4 liters. So that's about what it looks like. Called the molar volume because it's the volume of a mole. Okay, so this is a constant. It's always the same. And this is our conversion factor we're going to use. So when we work it out, comes out quite simple. All we're going to do, again, we're going to use the same process. So this problem here, I start by writing my given. I have 0.60 moles. Okay, I don't want the moles. It's asking for volume. And so again, that's my constant. It's always 1 mole, just like the other problems. And my constant is 22.4. Okay, I cross off my like unit. And I multiply, goes across. And that's it. That's all I got to do. It's always 22.4. It's a constant.